All right, so question 27, what does it say? I was trying to open the file from 4 after GCSE. Opening. Okay. Is this the question? Look at the screen. Is this the question?
Yes.
Yeah. Okay.
Yes.
So I'm going to walk you through what I mean by this. This is HL, that's eye level. Okay. Paper 2, time zone 1, because they have different time zones, even for IGCSE. I hope everybody's aware of that. Talk to me, please. Do you guys know about time zone in external exams? Yeah. So this is one time zone. I don't know, it could be some countries that will be awake by some time. So you don't want to have all the students around the world doing the same exam. So they have different time zone. And it was given in May 2011. So that's a long time ago. So that's the meaning of these references, that they are actually real exam papers. Okay, so it's a logarithm to base x plus 1, logarithm of y to base x plus 1 is equal to 2, logarithm of x to base y plus 1 is equal to 1 over 4. All right, let's see. Let's write today's date quickly. Today is it's a Monday. It's Easter Monday, actually. Do we have any Christian in the class? Anyone? No? I think we have a few Christians in the school. So, correction from the homework. Question 13. Log to base y plus 1, the number is x, is equal to, someone give me the question, please. Denise, do you mind? Or Rita, anyone? Is equal to what? 2?
2.
Okay. Then the second equation?
Log 1/4, I think.
Somebody confirm that?
Yes.
Okay, thank you. So these are the two equations. So can I have your attention, please? So that's equation 1. So the first thing I would do is to label them equation 1 and equation 2. Now, from equation 1, what do you suggest we do? Let's do this together quickly. From equation 1, we're going to rewrite in what form? Somebody?
Y equals to bracket x plus 1 to the power of 2 squared.
What? Where does that come from? Maybe you skip some things. You know, I don't like steps being skipped. Which one are you talking about? Because everyone is confused, including me.
The first one.
The first one, you said y equals to?
Wait, it should be x equals to bracket y plus 1 to the power of 2.
Yeah, that makes much sense. Now, that is rewriting in what form? Anyone? Come on, rewrite in what form? What are you, in which form? Anyone know the word? Index form. I mentioned that, index form. Do we remember now? Okay, so we want to rewrite in index form. So that's when the law 6 comes in. So from equation 1, so if you write in index form, log, we have equation 1 as x equals to y plus 1 squared, and equation 2, y equals to x plus 1 to power 1 over 4. So this is your equation 1. This is your equation 2 in index form. So we need to find a way to substitute something. Okay, so let's see. I hope this is not actually too complicated for you. So from the first one, I could say square root of x equals y plus 1, and square root of x minus 1 equals y. So I can put this into equation 2. If I put that into equation 2 has y equals actually 4th roots of x plus 1. Agree?
Oh, wait, Mr. Daniel.
Yeah.
I don't think the question is the correct one. I mean, like, isn't it?
Yeah, I think you
around?
miss x and y. That's why
Yeah. I think it's switched around.
What do you mean switch around? That's why I asked
Like,
someone.
it should be log to the base x plus 1, y equals to 2.
Oh.
And log y to base to y plus 1, x equals 1/4.
So this should be 1/4, this should be 2.
Yes, those two switch.
Yeah. Okay. Should I erase everything or just change the number here?
Just change the number there, it's fine.
So something like that.
Yeah, that's correct.
Okay. Okay, so from here, so this will be 1/4.
1/4.
And this will be 2. So we're still on the right track. So this will be from equation 2, not from equation 1. Then we'll be substituting in equation 1. Right? Right.
Mr. Daniel, I think for writing equation 1, you can just write x to the power of 4 equals to y plus 1 instead of square root 4.
You mean this one?
Yeah, you can just write x to the power of 4 equals to y plus 1.
Hold on, I'm writing from here, so I'm following the rule by not skipping anything. If
I know, but you put this, like, the last step, put this into equation 1 and you write y equals to square root 4x plus 1. I think this might be a bit confusing if you just write x to the power of 4 equals to y plus 1.
Oh, you mean the last one now will be different, yeah, because we just changed the equation. This is not the equation for the last one, right? So the equation will be from here. But we have made y the subject here. Oh, okay. So what I'm trying to do is to equate y and y. Yes, that's what we are going to do because the equation has changed. So from equation 1, this is what we have. Then definitely x to the power 4 is y plus 1. Definitely that's what we have to do. And your y is already here. So this will be x to the power 4 is equal to y is now x plus 1 squared, then plus 1. Okay? Okay, everyone? All right, so we're going to have x to the power 4. Oh, this is a polynomial of degree 2, of degree 4. So I'm not going to expect you to know how to solve this manually yet. Agree? Talk to me, please. Check. Is that correct?
Yes.
So we haven't done polynomial, so I'm going to solve this graphically. So we're going to have to solve this graphically. because we haven't done polynomial, how to solve equations like this.
For this one, you can factorize first, and then you can get an answer. But to solve another equation, like it's like you need to use graph to solve.
By factorization of polynomial of degree 4, you use something we call the remainder theorem and factors theorem. Have you done anything like that, Kelly?
Not yet.
That's why. You can factorize, I know, but we haven't done anything like that, so I won't force that on everyone. That's the point I'm trying to make. If x is actually -1, let's say, put x is equal to, this is what you have not done before. Put x is -1. This will be 1 minus 1. This will be +2 minus 2. Agreed? And that gives 0. So because x is equal to -1 gives 0, we say that x plus 1 is a factor. That's something called the factors theorem, but we haven't done this, so I can't force that on you. And so this is what I would have done. Okay, I'll show you. If this was a standard exam paper, which you have done the factors theorem and all that, from here, you will say, because I already know that when I put -1, it will give 0. I can, first I'll say, you will learn this later, guys. Let f of x be this. That's x to the power 4 minus x squared minus 2x minus 2. Then you put x is equal to -1. If you put x equal to -1, you have this. So the factors theorem says if f of a is equal to 0, then x minus a is a factor of f of x. Okay, that's what I'm using. So because when you put -1, you have that. The opposite of -1 is +1. Then x plus 1 is a factor. And since it's a factor, we're going to divide the left-hand side by that. Again, you have not done something called the division of polynomial. So that's why I'm talking about graphical method, Kelly. I know we can factorize, but the method of factorization is beyond the scope of our current learning. So I'm going to show it anyway, but we don't need to do this. Then we can see whatever we come up with on the graph. Now, if I divide this, I get x cubed. I'm sure not everybody knows what I'm doing. So you divide the first term by the first term, then you multiply it back. That's long division. So when I multiply, I get x cubed. The term x cubed is not included in the function, so that's why it is 0x cubed. So I multiply, I subtract now. This is 0, this is -x cubed. This is -x squared, bring it down. Just like when we divide numbers. If you do the next division, you have that. So at the end of the day, I'm still going to get the polynomial of degree 3, which I have to do this again for. Am I making sense, everybody? So which I have to do this again for. So that's why we will not waste time. If anybody needs this complete solution on this other way, let me know. But now we know this is -1, x plus 1 is a factor. It means at the end, okay, I'm going to complete this quickly. If I do this, I get that. I multiply back, I get that. And multiply by this, I get -x squared again. -x squared. This is -x cubed. So at the end, this will be 0, 0. So I bring down this. Sorry. Don't worry, class, about this process. It's something you will learn later. I never knew that question would lead to that polynomial. So, so this is the division thing. Now, this is what is happening. I'll give you an idea. We want to factorize 24. You already know that when 2 is divided by 24, the remainder is 0. then 2 is a factor. So because 2 is a factor, you divide 24 by 2, and you get 12. So 12 again, you break it down. You find one factor, you divide it, you get 6. Then you break it down again. 2 again can be used to break it down. You get 3. And this, so you see that these are all the factors. Then you write later that 24 is 2 times 2 times 2 times 3. So this is the factorization. That's what we are trying to do here. Does that make sense? That's what the polynomial topic is about. You will learn this later. So, but in algebra form. So x to the power 4 minus, because there's no x cubed, so it will be plus 0x cubed minus x squared minus 2x minus 2. So you always divide the first term by the first term. Whatever you get will be multiplied by everything. If you divide the first term by the first term, I have x cubed. You multiply by both of them, you have x to the power 4 plus x cubed. Then you subtract, just like we do in the long division of numbers. Remember, if you have maybe 3, 4, 1, you divide the first one and the first one, you get 1. You multiply back, then you subtract, then you bring down the next one. That's exactly what we are doing. So when you subtract here, you get 0. When you subtract here, you get minus x cubed. You bring down the next term, which is minus x squared. Then you do your division again, just like I would do my division again. I get 7. Multiply back, I get 14, and bring down this 1 because this is 0. That's what I've done here. So if you do that, you get minus x squared. This is minus x cubed. This is minus x squared. And the subtraction gives 0. You don't have to show it with a 0. Then you bring down this and this. You divide again, you get minus 2. Minus 2 times that is minus 2x. Minus 2 times that is minus 2. So this is 0. So basically, our f of x, which was x to the power 4, x squared, 2x, has now been factorized to give x plus 1. So that is this times this. Just like if you continue with this, whatever you have here times this is the answer. X plus 1 times x cubed minus x squared minus 2. Then here you look at this again because we wish to factorize this again. What are the factors and if there's a factor and things like that. At the end, when we factorize all this, we solve this by equating all this to 0. Then one of the answers will be x is equal to -1 and the other will be whatever we get from here. Does this make sense? What I'm saying a little bit. Does it make sense a little bit? But so this process, you don't need to worry yourself about it. Okay, it's called division of polynomial. Rather, what we are going to do is go online and plot the graph. Okay, we go online and plot the graph. So can everybody see my browser?
Yes. Yeah.
All right. So we go to desmos.com/calculator. Then we put in that equation that we have is equal to 0. Does anybody have it in their note to give me what that equation is?
X4 minus x squared minus 2x minus 2 equals to 0.
That's all you have to plot. If you plot this, so you could see that it touches how many places?
4.
Touches x-axis, Kelly. When you are saying
2, yes.
You are looking at how many places it crosses the x-axis. Where it crosses the x-axis is the solution. Okay? And one of them is definitely what?
-1.
-1.
That's what we have mentioned. The other one is this, 1.696. So those are the two answers for x. Okay? So because this is a polynomial of degree 4, we call it a polynomial of degree 4, you are not expected to use whatever right now. Of course, when you get to IB and you have learned how to deal with every form of whatever, then you can make use of that. So I'm going to erase this. because we don't need that factors, whatever, or maybe I leave it. I leave that. We don't need it, so I'm going to cross that part out of our solution. So this part is not necessary. Okay, so from this point, okay, from x to the power 4 minus x squared minus 2x minus 2 is equal to 0 by graphing x is equal to -1 or x is equal to 1.696 or 1.7. Does it make sense?
Yes.
I hope everybody understand why we meant that, because if y equals x squared minus 2x and y equals 0, to solve, we always equate both of them, right? Equating both of them, x squared minus 2x minus is equal to 0. So basically, this is the curve and this is the line. That line, y is equal to 0, is your x-axis. And that's what has happened here. So here you're actually looking at where this curve that we have plotted intersects with the x-axis, which is y is equal to 0. So this is y, and this is another y. Does that make sense, everyone? So that's the reason we are looking at where it crosses the x-axis, but we are looking at where they meet. Okay? So that's that. So once we know our x, then we substitute back into y. So we can make use of this because it has y. We don't have to waste time doing anything else. Okay? So we can put into equation 2. So put x into equation 2. Equation 2 says y equals x plus 1 squared. I check that. Yes. So for the first one, y will be minus 1 plus 1 squared. For the second, y will be 1.696 plus 1 squared. So this is equal to 0. So this is equal to 2.696 squared. Can somebody confirm that in 3 significant figures?
7.27.
7.27. So this we could actually write as 1 point, or maybe 3 decimal places. Let's use 3 decimal places again. 7.2, 3 decimal places instead of this. Joey, what did you do to your background? Your face is
7.268.
okay, 7.268, like that.
Yeah.
So the solution, therefore, x is equal to -1, y is equal to 0, or x equals 1.696, y equals 7.268. If you don't write it that way, you could say the solution is, or the solutions are, you can put it in coordinate form, -1, 0, and, actually this should have been and 1.696, 7.268, something like that. Does this make sense? So that's that. Any other question? I didn't know you were going to get polynomial of degree 4, so maybe I wouldn't have given you that. Oops, sorry. So we have a few minutes. So let's see. I'm interested in two types of questions. So I will just go straight to the example. We'll solve it together in the next 9 minutes or 10. Your next class will be by 12:20. So, so let's see. Look at set of questions number 30. Who's that?
喂，妈，我在上课，我正好课打给你，拜拜。
Oh wait, Shankar means I'm in class, right?
Oh
Yeah.
my god, I forgot to mute myself. Sorry.
Don't worry, I'm also practicing my Chinese, Kelly. Since you have refused to teach me, now I'm showing off. Shankar means in class, right?
Yeah, I told my mom I was having class, so I'll call you later.
You see, I'm good. I know that. All right, that was nice. It's actually the first time Kelly speaks and I can spy on what she's saying. So if Kelly's planning on gossiping behind me now, I probably know. You want to think twice. Just kidding. It'd be nice when school resumes and you guys can speak some Chinese to me. Anyways, so can you see what I'm looking at? Question 30. So I want us to do maybe one of these. Question 30A, then maybe you can do 30B later. Then I want us to do, before 30, the one that leads to quadratic. Yeah, this set. So we'll focus on question like 26 and 30. So because of the time, I don't know what's going on. I will just go straight to the how to solve it. All right. So let's begin. Question 26. Let me see which is more technical and can give you problem. Okay, I'll take 26G. Okay, I'll take 26G. So this type of question leads to non-linear equations. Okay, so let's try. More logarithmic equations. So 26, someone is trying to join. Oh, Karen, not now. Wait, when is my IB class? It's 11:20. Why is Karen joining so early? Anyway, let her in. So question 26A, 26G, sorry. 26G says, can someone call that question for me so I don't have to open two different windows? Thank you, quickly.
Log base 4
Log
x
base 4 x
plus log base x 16 equals 3.
Equals 3? Good. All right. So that's what we have. So everybody, I need to have your attention. You can copy this later. Please listen first. So this is 26G, in case you're wondering. So the idea here is to have something that looks similar. You want to have the same, actually, not just similar. You want them to be the same. Now, this can't be the same. There's no way we can change this to this, but we can actually write this as 4, right? So we're going to change this to 4. Then we're going to use the inverse of log principle. So I'm going to leave this as log to base 4, log x to base 4, actually, that's what we call it. And this will be 4 squared 16 equals to 3. Then this will be log x to base 4, while this is 2 log, okay, 4 to base x equals 3. So this is the general way that this is general form that most of the question will look. But even like this, it still doesn't look nice because the bases are different, so you can't think of anything. And even now you have 2 at the back, so even if the bases are the same, you can't multiply them anymore. So what you will do is you're going to rewrite the first one, or maybe the second one, or maybe I'll leave this first. Change. You have 2 ways. Use different color. The first way, you can decide to change to base 4, or you can change to base x. Your choice. Because we could see that you can either have base 4 or you have base x. Okay? So you have to be consistent. Okay? Change to either base 4 or change to base x. So I'm going to first change to base 4. If you change to base 4, this is okay. Do you agree with me? Come on, come on, come on. I need some statement. Thank you. So this is not okay. Can anybody tell me, using the laws of logarithm, if I need to change this to base 4, what do I get?
Log base 4 divided by log base 4x.
Okay, so we do log base 4 divided by log base 4. Then 4 here, x here. This is 1. So that's 1 over, okay? This is already a principle that we learned before, so you don't have to go through this. Okay, we already have a law. Can somebody look at those laws of logarithm? I call it reciprocal of logarithm. Are you playing?
Law 8.
Law 8. Everybody look at law 8 in your notebook. Have you all seen it?
Yeah.
So by law 8, I can write this way. That's the point we're trying to make. I'll use law 8. Okay, but this is what has happened. What Candy said is exactly what has happened. But you can write directly. Okay, and remember that 2 log whatever means 2 times log whatever, so which means 2 times 1 over log, and that is why it is 2 over log. That's how we got this. Okay, so do I need to show those steps, class?
No.
No.
It's fine.
Fine. Okay, thank you. I'm treating you like mathematically mature student. So if I'm wrong, please call me back. The idea is to learn, not to show off. Okay. If something is not clear, please feel free to speak up immediately. All right, quickly, because it's actually 1 minute our normal time. So when you get to this point, listen, when you get to this point, now you have consistent, right? But something is weird about the way it looks. Can somebody tell me why, Denise, you are writing? I can see you writing. You are not listening. You are not listening. Shirley, you are not listening. I need you to listen and follow through with this solution. Thank you. Okay, so when we get to this point, tell me how this is different from the normal logarithmic equation. Because normal logarithmic equation that you are solving in the past, you have maybe log x, maybe 2 plus 1, whatever. Then you have another log x plus or minus. Tell me why you can't apply your laws immediately on this. Quickly.
It's a fraction.
It's a fraction. The log is here. The log is not at the top, so there's a problem. So this kind of situation, you can't apply what you already know. What you need to do is to say, let's log, that log that looks consistent, be some variable m. Some can do it without that. So then the whole equation becomes m plus 1 over m equal, no, 2 over m. So everything becomes m plus 2 over m equals 3. Am I making sense?
Yes.
Yeah.
All right. So now this leads to a quadratic equation. When you multiply through by m squared plus 2 equals 3m. Understood? Okay. This means m squared minus 3m plus 2 equals 0. Okay, my M looks horrible. Mute yourself, please. So which means we have, it's a monic equation, so it's easy to factorize. M minus 1, M minus 2 equals 0. So from here, either M minus 1 is equal to 0 or M minus 2 is equal to 0. So M is equal to 1 or M is equal to 2. But M is not the variable, so you come back here. Recall, log 4x equals M becomes log 4x equals 1 or log 4x equals 2, right?
Yeah.
Denise, confused? No. So you can apply the law 6 now. From here, x is equal to 4 to the power 1. From here, x is equal to 4 to the power 2. We are not fabricating anything. Whatever you do must be logical, must be sensible, must be in accordance with the laws that we have learned, not what you think. So from here, x is equal to 4 or x is equal to 16. The second method, I'll write it as DIY. In the second method, I'll just write the first step and I need you to complete that on your own. So in the second method, from here, so this is method 1, begins from here, the red part. Method 2 is this. You just change to base x. So from here, you change the base to base x. And if we change to base x, can we write it together? What happens to this step when we change to base x? Log 4x, this is what we had before. So if I change to base x, what do I get?
One over
1.
log base x 4.
Agreed? Then here you can say let's log 4 to base x be some variable, maybe r. Then you have 1 over r plus 2r equals 3. And I need you to complete that, DIY. Okay, so you're going to get the same set of answers. So when you have a situation like that, sometimes you are not having the beginning as this. It comes as 4, 4, xx like that. So it's easy to do this. Sometimes it comes indirectly. So you need to actually do what I did. Am I making sense? My point is the question can come with this as 4 directly. So that means you are in this step already. Okay? And sometimes you need to actually manipulate. If this is 3, this could be 27. You need to actually make it look similar first, then work towards your consistency. Please talk to me. Everybody understood this or not?
I understand.
Yes.
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 So that's how to solve questions like that. The last one also will be a DIY, so we can leave. The question 30, give me question 30. I want to quickly rush through this so you can do it on your own. Question 30, A is easy. Maybe 30, yeah, B is also easy. None of them is difficult. Okay, so maybe 30B. 30B, give me the question 30B. Guys, I have from 5 class. I'm sure everybody heard me.
Um, 2 log base 5x.
Andy isn't the only one in the class, so someone else, thank you. And not Kelly too, she has spoken enough today.
Is it 30B?
30B, yeah.
It is
2 log base 5 x
2 log x base 5.
plus 6 log y base 9
6 log y base 9
equals 16.
equals 16.
And then the second equation is 5 log x base 5 minus log y base 3 equals 6.
This looks more than I thought. Base. So this is 9 and this is 3, right, Justin?
Yes.
Okay, so it's actually not a linear equation. I thought it would lead to linear equation, but apparently not, because this is 3, this is 9, this is 3, so they are not the same. Now, if this was 3, if you had maybe log, like the first one should be easier for you, that's the A part, that's the one I will ask you to do, but someone can look into this also. The next class we solve it together. If this was log 5x plus maybe log 3y, maybe it's equal to 1, and this is maybe 2 log x5 minus 3 log y3 is equal to maybe 6. Now, because this and this are the same, this and this are also exactly the same, what you do is to introduce 2 variables. Let log x to base 5 be A, and let log y to base 3 be B. Then your equation becomes A plus B equals 1, 2A minus 3B equals to 6. Then you solve the equation, just like we solved this M, and use recall to write the answer. Does that make sense? But in this case, they want us to do extra work. So the extra work will be to change this, the base. If you can change the base, so change base, base 9 to base 3. So I don't have any issue with equation 1. I only equation 2, I only have issue with equation 1. So if I change the base 9 to base 3, the first one becomes, quickly, I have IB class in 11 minutes, and you also have class in 11 minutes, I believe. So this will be log base 3 y log base 3 9, agreed? Equals 16. So that becomes 2 log x5. This will be 6 log base 3 y. Now this is going to be 2. Agreed? So this is 3 squared. Okay. 2 log. 2 comes backward, and I can cancel that as 1. So I want to skip that step. So 6 log, maybe I just write. So 2 log 3 base 3 equals 16. I'm writing this so-called full detail because once we establish the equation, you really want to continue and solve it with the other one. Quickly. The time is short and I don't want us to drag this topic too long. So that's why I want to introduce you to the idea, then you can continue on your own. So that becomes 2 log 5x. Now this is going to be 2 divided by 6, and this is already 1. Do you agree?
Yes.
Okay, please respond and fast. So that would be 3. So now equation 1 looks better. And joining with equation 2, you see that? So this is exactly what you must always try to achieve. So when you get to this point, the rest is what I just told you in the other one. So what you need to do for this type of question is to introduce different variables because they all look alike, right? They look alike in both equations 1 and 2. Let's log 5x be A. Introduce 2 variables, preferably consecutive letters. And let this be B. Then the two equations that you have becomes 2a plus 3b equals 16, 5a minus b equals 6. So now, if I call this equation 1, this as equation 2, you can label this equation 3 and this equation 4. So solve for a and b, put it back here, and that is how to get your x and y. So DIY, please. Okay, so let's log out now. We still have 9 more minutes before your 8 more minutes. Take some break or complete your note. I'll send you this screenshot immediately after the class. You can. So for the homework, before Wednesday, the question that you will be required to do, please take notes quickly, will be in 26. In question 26, I'll give you 5 problems altogether. We've completed G. I need you to do the second part of G. Okay, I need you to do 26A, 26B. You don't have to rush all that because we can still practice more next lesson. 26A, 26B. Complete the second approach of the other one. Use any, either you use base X or you use base 4, it doesn't matter. So you don't have to do both methods. You can do both methods to satisfy your curiosity. You don't have to send me the 2 solutions, please. So 26A, 26B, that's for 26. Then in 30, I need you to do 30A and 30B. Of course, we have started working on 30B, so just complete it at your work as well, okay?
Mr. Daniel?
Yes, quickly.
I think last time you gave us 30A already. I think we did it.
Really? 30?
Yeah, we did 30A.
You did that as homework?
Yeah.
Were you able to use simultaneous equation like I just explained?
Yeah, that's what I
Yes.
did.
Oh, I didn't know I'd give you that. Okay, so complete 30B and no need for 30C and D. I just want us to focus on that. Then in that case, 30A, 30B, can I ask you to attempt F and I? 26. 26A, B, F and I. 26A, B, F and I, then 30A. So homework, I write it on the board.
No 26G.
Okay, I'm confused now, just a sec. Homework, did you say 26G, Justin?
It's the one you said DIY.
Oh, I thought I finished that. I did one part. The other part is just for you to complete the second approach in your notebook. It's not homework.
Oh, okay.
You can see how both works, that there's no difference whether you change the base to X or you change the base to 4. It's just for you to know. So when you're doing A, B, F, and I, you don't have to show me the 2 methods. Just focus on either base 2 or base X or whatever. That's my point. Okay, Justin? Okay, so we have 6A, B, F, and I plus 30B, right? Or is it 30A?
B.
30B. All right. 30B, we've started already. You just complete it as homework. Okay? I'll see you next time. Bye now.
Bye-bye.
Bye.
Bye.